As you settle into your blankets tonight, take a moment to notice the stillness of the room around you. The world outside has slowed its pace, the distant hum of traffic has faded, and the air feels cool and steady. You are safe, you are comfortable, and for the next little while, there is nothing you need to do and nowhere you need to go. But even in this deep quiet, something extraordinary is happening. Right now, as you lie perfectly still, microscopic pieces of distant stars are softly landing on your roof. It is a silent, visible rain from the cosmos, a gentle dusting of the universe settling upon your home while you rest. Welcome to Sleepy Science. This is a space designed for your mind to wander through the wonders of the natural world at a pace that invites sleep. My voice will be your guide, sharing the quiet truths of our universe as you drift closer to dreams. There is no rush here. We will explore the vast and the microscopic, the ancient and the current, all with the goal of helping you find a peaceful path to rest. We will speak of things that are true and steady, facts that ground us in the majesty of the world without demanding too much of our tired minds. These tiny visitors landing on your shingles and in your garden are known to scientists as micrometeoroids. They are often far smaller than a single grain of sand, sometimes no larger than a speck of wood smoke or a fragment of fine silk. To the naked eye, they are invisible, lost among the common dust of our daily lives. Yet, each one carries a story that began millions of miles away in the cold, dark reaches of the solar system. They are the debris of ancient collisions, the crumbs left behind by wandering comets, and the elemental remnants of stars that burned out long before our world was even a thought. These are not the bright, blazing fireballs we sometimes see streaking across the night sky, but rather a soft, persistent mist of matter that the earth gathers as it moves through the void. Imagine one of these tiny particles right now. It is a speck of iron or perhaps a glass-like crystal of silicate drifting through the dark. For eons it has known only the silence of the vacuum and the pale light of distant suns. But now it has found its way to Earth. Let us leave the comfort of your room for a moment and travel upward, following the path this particle took to reach you. We pass through the ceiling, through the quiet night air above your house, and rise past the tops of the tallest trees. We climb higher and higher through the thinning blue of the sky until the air becomes cold and rare. Here, at the very edge of our atmosphere, where the velvet blackness of space begins to meet the protective, glowing veil of our world, is where the journey of the cosmic dust truly begins. It is here, in the high, silent reaches of the ionosphere, that the silent travelers first touch the hem of our planet, beginning a slow, graceful descent that will eventually bring them home. As we linger here at the edge of the atmosphere, I want to take a moment to invite you to join our quiet circle. If these stories of the stars help you find your way to sleep, please consider subscribing or leaving a gentle like. It is a small way to ensure these restful nights continue, whispered softly, so as not to disturb the stillness of your room. Now, let us bring our focus back to the body for a moment. Take a slow, deep breath. Feel the cool air enter, and as you exhale, feel your muscles begin to let go. Notice the weight of your limbs. Your arms feel heavy and warm against the sheets. Your legs are sinking deeper into the bed, as if gravity is pulling you into a soft, safe embrace. You are grounded. You are safe. You are part of the earth, resting while the universe continues its slow, rhythmic dance above you. While you lie in this perfect stillness, consider the sheer volume of the cosmic rain we spoke of. It is difficult to imagine, but our planet is constantly growing, bit by tiny bit, every single day. As Earth travels its path around the sun, it collects between 60 and 100 tons of space material. It is a staggering amount, the weight of a dozen large elephants or several fully loaded trucks falling from the sky every 24 hours. Yet, this mass isn't made of giant boulders or crashing asteroids. Instead, it is composed of billions upon billions of microscopic specks. If you were to hold a handful of this material, it would feel like the finest silk or the softest ash. This 100-ton gift from the cosmos is spread across the entire surface of our world. Every square inch of the Pacific Ocean, every leaf in the Amazon, every grain of sand in the Sahara, and every tile on your roof receives its tiny portion of the stars. It is a constant, silent accumulation that has been happening for billions of years. If we could see time sped up, we would see the Earth moving through space like a ship sailing through a light, eternal snowstorm, its hull gathering a thin silver coating as it goes. We are not just moving through an empty void. We are passing through a crowded neighborhood of ancient history. But where does this journey truly begin to slow down? To find out, we must look at the invisible barriers that protect us. The dust doesn't just fall. It must first navigate the high, thin reaches of our world's outer shell. It is a journey of friction, light, and incredible physics that begins nearly 60 miles above your head, in a place where the air is so thin it feels like a dream, yet strong enough to catch a traveler from the stars. Imagine the very edge of our world. This is the thermosphere, a vast and silent region where the atmosphere begins to thin into the true nothingness of space. It is a place of extreme contrast, where the sun's rays are fierce, yet the air is so sparse that a human would feel only the deepest, most profound cold. It is here that our tiny travelers from the stars make their first contact with Earth. Most of these particles are incredibly small, almost beyond our everyday perception. Scientists have found that the majority of these micrometeoroids are between 0.05 and 0.5 millimeters in size. To help you visualize this as you drift towards sleep, imagine the very tip of a fine sewing needle or a single grain of the softest salt. They are so small that they are nearly weightless, yet they carry with them the incredible momentum of a journey that may have spanned millions of miles through the dark. When these particles hit our atmosphere, they are traveling at speeds that are difficult to comprehend, sometimes over 40,000 miles per hour. Usually, when something enters our atmosphere at those speeds, like a large meteor or a returning spacecraft, the friction of the air creates an intense, white-hot heat. We see this from our windows as a bright, sudden streak across the night sky, a shooting star that burns itself away in a single moment of glory. But these tiny micrometeoroids are different. They are so small that they often survive this fiery ordeal completely intact. You might wonder how something so delicate, so microscopic, could survive a heat that would melt solid rock or vaporize iron. It feels like a small miracle of the cosmos. But it is actually a beautiful and simple piece of physics. Because these particles are so tiny, they have a very large surface area compared to their very small mass. As they begin to heat up from the friction of the air, they are able to radiate that heat away into the cold surrounding space almost instantly. This process is known as thermal radiation. It is as if the particle is a tiny, perfect radiator, cooling itself down just as fast as the atmosphere can warm it up. Instead of burning into ash, they simply slow down. They experience a soft braking, losing their incredible cosmic speed and beginning a long, peaceful drift toward the ground like a feather settling through a still room. In the darkness of the high atmosphere, these particles don't look like burning fireballs. Instead, they remain as they were, tiny, dark or translucent grains of mineral and metal, invisible to the naked eye. But as they gather in the vast seas around our world, they do something remarkable. Before they even touch our air, while they are still floating in the neighborhood of the planets, they interact with the light of the sun in a way that creates one of the most subtle and beautiful sights in the natural world. They form a shimmering, quiet presence that tells us the space between the planets is far from empty. It is a mist of ancient light, a glittering veil that stretches across the solar system, waiting for the right moment to be seen. Imagine for a moment that you're standing in a very dark place, far from the lights of any city. The sun has just dipped below the horizon, and the sky is beginning to fill with stars. But there, stretching up from where the sun disappeared, is a soft, ghostly pyramid of light. It is a faint, glowing triangle that seems to reach toward the center of the sky, thinner and paler than the Milky Way. This is the zodiacal light, sometimes called the false dawn or the false dusk. It is one of the most quiet and beautiful secrets of the night sky, and it is the visual proof of the dust we have been talking about. This glow isn't coming from the atmosphere of Earth, nor is it coming from the stars themselves. Instead, you're looking at the reflection of our own sun bouncing off a vast, invisible structure known as the interplanetary dust cloud. This cloud is a massive, disc-shaped haze of particles that fills the space between the planets, concentrated mostly along the path the sun takes across our sky. When we see that triangular glow, we are actually seeing the sun's light scattering off trillions and trillions of those tiny micrometeoroids, each one no bigger than a speck of soot. It is a profound realization to think that the space between the worlds is not a cold, empty vacuum. It is, instead, filled with a thin, glittering mist. If you could fly through it in a spacecraft, you might not even notice a single grain. Yet, when you step back and look at the solar system as a whole, it is as if the sun is sitting in the middle of a dusty room illuminated by a single bright beam of light. Think of a sunny afternoon in an old house, where a ray of light spills through a window and reveals thousands of tiny motes dancing in the air. Without that light, the room looks empty. But with it, we see that the air is alive with texture. The zodiacal light is exactly that, the sun's light revealing the texture of the solar system. This cloud is vast, stretching from the sun out past the orbit of Mars and into the asteroid belt. It is composed of the very same particles that are, at this very moment, drifting down through our atmosphere. and landing on the rooftops of our homes. They are the leftovers of creation, the crumbs of the solar system that never quite became part of a planet. They swirl in a slow, eternal dance, held in place by the delicate balance of gravity and light. This mist is always there, even when we cannot see it, a silent witness to the history of our cosmic neighborhood. It surrounds us like a soft, dusty blanket, a reminder that we are never truly alone in the dark. But as you lie there, perhaps wondering where such a massive amount of material could possibly come from, we must look to the edges of our system. For the cloud to remain so thick and so visible after billions of years, it must be constantly fed. It needs a source, a way for new, fresh dust to be born into the void. And that source lies in the wandering travelers of the outer solar system, the icy giants that occasionally visit our inner warmth, shedding their frozen skin as they go. To understand where this vast shimmering cloud of dust comes from, we have to look toward the visitors from the farthest, coldest reaches of our solar system. These are the comets, those wandering nomads that spend most of their lives in the deep freeze of the Oort cloud or the Kuiper belt, far beyond the warmth of any star. Scientists often describe a comet as a dirty snowball, but perhaps it is more accurate to think of them as cosmic time capsules made of ancient ice, frozen gases, and a generous dusting of soot and minerals from the very beginning of time. As a comet begins its long, slow journey toward the sun, something beautiful and transformative happens. The sun's warmth, even from millions of miles away, begins to touch the comet's frozen surface. In the vacuum of space, the ice doesn't melt into water. Instead, it turns directly into gas, a process called sublimation. As the ice vanishes into the void, it releases the billions of tiny particles of dust and rock that were trapped inside it for eons. This release creates the comet's coma, a glowing, ghostly atmosphere that surrounds its icy heart. But the comet doesn't just hold on to this dust. The pressure of sunlight and the solar wind push these particles away, stretching them out into a magnificent, glowing tail that can span millions of miles across the blackness. This tail is not just a trick of the light, it is a physical trail of crumbs left behind in the comet's wake. Imagine a traveler walking through a deep, snowy forest, leaving a long line of footprints behind them. A comet does the same, but its footprints are made of microscopic silicates and grains of carbon. As the comet rounds the sun and heads back into the cold dark, it leaves this trail of debris suspended in space, marking the path it once took over thousands of years. These trails spread out, merging with the paths of other comets to form the great interplanetary dust cloud we spoke of earlier. It is a quiet, ongoing replenishment of the solar system's texture. These grains are so light and so small that they can remain adrift for millions of years, caught in the sun's gravity like a slow-motion whirlpool. You might think of these comet trails as ghost roads in the sky. They are invisible to the naked eye most of the time, yet they are very real. And every so often, our own planet, Earth, in its steady rhythmic orbit around the sun, finds itself crossing one of these ancient paths. When we do, we encounter the very same dust that was once frozen inside a dirty snowball billions of miles away. It is this intersection, this meeting of Earth's path and the comet's trail, that creates some of the most magical sights we can see from the comfort of our windows at night, turning those tiny crumbs into streaks of light that dance across the dark. Every year, at almost the exact same time, our planet returns to these celestial crossroads. You may know them by their names, the Perseids in the warm, velvet air of August, or perhaps the Geminids in the crisp, clear dark of mid-December. These are the famous meteor showers, the times when the night sky seems to wake up with sudden, fleeting streaks of light. To someone watching from a lawn chair or through a bedroom window, it feels as though the stars themselves are falling. But in reality, we are simply passing through one of those invisible ghost roads we spoke of, the debris path left behind by a comet long ago. Imagine for a moment the scale of this encounter. Earth is a massive, silent sphere, traveling through its orbit at an incredible speed, about 67,000 miles per hour. As we move, we are essentially plowing through the vacuum of space. Most of the time, that space is relatively empty, but during a meteor shower, we are driving head first into a dense cloud of comet crumbs. It is like a ship sailing through a patch of bioluminescent plankton in the dark ocean. The ship's movement creates the light as it disturbs the water. When you see a shooting star zip across the sky, leaving a glowing trail that lasts for just a heartbeat, it feels like something substantial must be happening. You might imagine a large rock, perhaps the size of a chair or a car, colliding with the air, but the reality is far more delicate and perhaps more beautiful. The vast majority of those brilliant flashes are caused by particles no larger than a single grain of sand, a small pebble, or a grain of rice. As these tiny fragments hit our upper atmosphere at tens of thousands of miles per hour, the friction of the air creates an intense heat. This heat doesn't just burn the particle, it ionizes the air around it, creating a glowing tube of hot gas that we see from the ground as a streak of light. It is a profound thought to hold as you drift toward sleep, that a tiny speck of dust, smaller than the tip of a pencil, can illuminate the entire sky for a moment before it vanishes. It is a grand performance by the smallest of actors. The Perseids, for example, are the remnants of a comet called Swift-Tuttle, which takes over 130 years to orbit the sun just once. Every time it passes by, it refreshes that trail of crumbs. And every August, Earth faithfully returns to the spot where those crumbs are waiting. The Geminids are slightly different, coming from a mysterious object called 3200 Phaethon, which behaves like a comet but looks like an asteroid. Regardless of their source, these particles are the messengers of the deep solar system, finally reaching the end of their multi-million-mile journey. But not every piece of space dust makes such a dramatic entrance. While the larger grains, those the size of a marble or a pebble, create the bright flashes we call meteors, there are countless other particles that are much, much smaller. These are the truly microscopic drifters. They are so light and so tiny that they don't create enough friction to burn up or glow. Instead of a fiery end, they experience a very different kind of arrival. While the shooting stars capture our attention with their brief, bright lives, it is these invisible drifters that perform the most patient journey of all, slowly beginning their long, silent descent toward the world below. Imagine the silence of the upper atmosphere, miles above the clouds where the air is thin and the sky begins to fade into the deep black of the cosmos. In this quiet realm, the journey of a micrometeorite changes from a high-speed arrival into a slow, meditative descent. While the larger meteors we call shooting stars are gone in a flash of light, these smaller particles begin a long, unhurried drift toward the Earth. For these tiny travelers, the atmosphere doesn't feel like empty space. Instead, it feels more like a thick, invisible fluid. Imagine a single microscopic leaf falling from the top of a giant tree on a day when there is no wind at all. It doesn't plummet, it sways and lingers, caught on the invisible currents of the air. To a particle smaller than a grain of flour, the molecules of nitrogen and oxygen in our atmosphere act like soft cushions, slowing its fall until it is barely moving at all. This descent is a lesson in patience. Scientists have found that a micrometeorite can take several weeks, or in some cases, many months, to drift from the upper reaches of the thermosphere down to the surface of the planet. While we go about our lives, sleeping, waking, working, and dreaming, these tiny pieces of the universe are suspended high above us. Slowly sinking through the layers of the sky, they pass through the stratosphere where the air is cold and still, and then down into the troposphere where the weather lives. They are like tiny silent ghosts, invisible to the eye but present in staggering numbers. As you lie there, perhaps you can visualize one of these particles right now. It is high above the roof of your house, perhaps still miles up in the air, slowly circling and settling, moving just a few inches every hour. It has been traveling for billions of miles across the solar system, and now it is taking its time for the final few miles of its journey. There is something deeply comforting about this slow, inevitable process. The universe is not always in a hurry. Its most profound movements are the ones that happen so slowly we can barely perceive them. These particles are not just empty dust. They are complex little worlds of their own. As they drift through the stillness of the upper air, they carry within them a specific chemical signature, a fingerprint of the place where they were born. To understand what these particles are, we have to look closer at their physical makeup. If we were to hold one of these microscopic drifters under a powerful lens, we would see that they aren't just random bits of debris. They are composed of very specific materials, many of which are remarkably familiar to us here on Earth. Yet they have a history that stretches back to the very dawn of time. Their composition tells a story of intense heat, ancient collisions, and the very building blocks of the planets themselves. As we look closer at these microscopic travelers, we find that many of them belong to a very specific family of minerals called silicates. If you've ever walked along a beach and felt the soft, cool grains of sand beneath your feet, you've encountered silicates before. They are the most abundant minerals in the Earth's crust, forming the foundation of our mountains and the floor of our oceans. It is a quiet, comforting realization to know that the dust from the stars is made of the same basic ingredients as the Earth beneath our beds. But the story of these silicates doesn't begin on a beach or in a mountain range. It begins in the unimaginable heat of a distant star. You see, the universe started with very simple ingredients, mostly hydrogen and helium. The heavier elements, like the silicon and oxygen found in these dust grains, had to be manufactured. They were forged in the hearts of stars through a process called nucleosynthesis. Imagine a star as a great glowing furnace, pressing atoms together with such force that they fuse, creating entirely new elements. Deep within that celestial heat, silicon atoms are born. When a star reaches the end of its life, it doesn't simply disappear. It breathes its contents out into the darkness of space, scattering these newly formed elements like seeds across a garden. This is why, when we speak of stardust, we aren't just using a poetic metaphor. It is a literal, physical truth. Every grain of cosmic dust currently settling through our atmosphere is a piece of a star that lived and died long before our own solar system was even a glimmer of gas. These particles are the physical remains of ancient suns. They have traveled across the vast cold reaches of the interstellar void, carrying the history of the galaxy within their tiny silicate structures. There is a profound sense of continuity in this. The universe is a master of recycling. Nothing is ever truly lost. It only changes form and purpose. A star burns brightly for millions or billions of years, and when its fire finally dims, its essence is cast out to become the dust that eventually forms planets. As you lie there, breathing slowly and deeply, you might feel a connection to this grand cycle. The very same elements that make up the dust on your windowsill and the very same elements that make up the minerals in your own body were once part of that same stellar process. We are part of the same story as the drifting micrometeorites. We are made of the same ancient materials forged in the same celestial fires. This connection to stellar evolution goes even deeper. While many of these particles are simple silicates, some carry even heavier elements, the kind that can only be created during the most dramatic events in the universe. These heavier bits of debris tell an even older and more powerful story, one that involves the most massive stars in existence and the spectacular ways they conclude their journeys through the cosmos. When these giants reach their end, they leave behind more than just dust. They leave behind the building blocks of everything we know. Among these building blocks are the heaviest elements, the ones that require the most extreme conditions to exist. To find their origin, we must look to the most massive stars in the cosmos, stars many times larger than our own sun. These giants live fast and die magnificently. When they reach the end of their lives, they don't simply fade away. They undergo a supernova, a cosmic exhale of such power that it creates elements like iron and nickel in a single, brilliant moment. This process is the universe's way of enrichment. As the star expands and then releases its outer layers, it ejects these heavy elements into the interstellar void. Imagine these particles, microscopic specks of iron, floating in the silent, dark reaches between the stars. They are travelers, embarking on a journey that will last for millions, perhaps billions of years. It is a slow, quiet journey through the velvet blackness. You might wonder how something so small, cast out from a distant explosion, could ever find its way here, to this quiet room where you are resting. The answer lies in the gentle, invisible currents of the galaxy. The space between stars is not truly empty. It is filled with a very thin mist of gas and dust known as the interstellar medium. Over vast stretches of time, the gravity of other stars and the pressure of starlight push and pull these particles, guiding them across the light years like tiny ships on a vast, dark ocean. Eventually, some of these wandering grains find their way into a massive cloud of gas and dust, a nebula. This is where new stars and planets are born. When our own solar system began to take shape 4.5 billion years ago, it acted like a great cosmic net, sweeping up the dust that had been drifting through the neighborhood. These supernova remnants became the seeds for everything we see around us today. They are the foundation upon which planets are built. Without these specific heavy particles, the Earth would be a very different place. The iron that settled into the center of our planet creates the magnetic field that protects our atmosphere. The nickel and other metals found in the Earth's crust are the very same materials that have been recycled through the eons. But more than that, these particles are the seeds of life itself. It is a staggering yet deeply comforting thought to hold as you drift toward sleep, that the very material of the world, the solid ground beneath your home, and even the minerals that sustain your own heartbeat were once forged in the heart of a dying star. They were carried here on the back of a microscopic grain of dust, drifting through the silence until they found a home. Take a moment now to feel the weight of your body against the mattress. Feel the stillness of the air in the room. You are part of this grand celestial distribution. You are a collection of those ancient seeds gathered together in a beautiful, living form. The same stardust that is falling softly onto your roof tonight is the same material that built the foundations of your world. We are not separate from the stars. We are their legacy, resting quietly in the dark, connected to the very beginning of time through the simple, silent presence of dust. As you lie there in the quiet of your room, take a moment to notice the weight of your head against the pillow. Let your jaw go loose, releasing any tightness you might be holding in your teeth or your tongue. Feel your shoulders soften, sinking just a little deeper into the mattress, as if the gravity of the earth is gently pulling you into a state of perfect rest. There is no hurry here. There is only the slow, steady rhythm of your breath and the vast, silent story of the cosmos unfolding around you. It is a profound realization to consider that the connection between you and the stars is not merely a poetic thought, but a physical reality. The very same elements that make up the microscopic grains of cosmic dust drifting through the night are the building blocks of your own body. Scientists have found that the most essential ingredients for life, carbon, nitrogen, and oxygen, are the primary components of the dust clouds that fill our galaxy. Every breath you take, drawing in oxygen to nourish your cells, is a connection to a process that began billions of miles away and billions of years ago. The carbon that forms the structure of your DNA was once forged in the intense heat of a star's core, later scattered into the void to become part of the very dust we have been discussing. In a very real sense, the universe operates on a grand, elegant recycling program. Nothing is ever truly lost. It is simply rearranged. An atom of nitrogen might spend 100 million years trapped in a frozen comet, another 50 million years drifting as a lone speck of dust, and then, through a series of quiet miracles, find its way into the soil, then a plant, and eventually into the very fabric of a human life. We are the universe looking back at itself, composed of the same ancient materials that once shimmered in the darkness of the early solar system. This cycle of birth, dispersal, and reorganization is constant and incredibly slow, moving at a pace that mirrors the stillness of a deep sleep. As these particles land on our planet, they are not strangers. They are the return of long-lost relatives, coming home to join the great collection of matter that makes up our world. But while we share the same chemical heart as these cosmic travelers, their physical forms are shaped by the incredible journey they take to reach us. If you were to look at a single grain of this dust under a powerful microscope, you would see that it doesn't look like a jagged piece of rock or a common grain of sand from a beach. Instead, many of these tiny visitors have been sculpted by their passage through our atmosphere into something quite beautiful and unexpected. Their appearance is a testament to the heat and the friction they endured to arrive here, transformed from a rough fragment of the void into a tiny, delicate work of art. To understand what these grains truly look like is to see the physical evidence of their transition from the cold vacuum of space to the warm embrace of the earth. As you settle deeper into the stillness of your room, try to visualize the physical transformation of these tiny travelers. When a piece of cosmic dust meets our atmosphere, it is moving with such incredible velocity that the air itself becomes a wall of heat. In a matter of seconds, the temperature of the grain rises to thousands of degrees. This flash heating is so intense that the microscopic rock doesn't just glow, it melts completely. For a fleeting moment, as it streaks through the high, thin air of the thermosphere, the solid grain becomes a liquid droplet, a tiny bead of molten star stuff suspended in the sky. In this liquid state, the laws of physics exert a gentle but firm pressure. Just as a bead of water on a wax surface pulls itself into a rounded shape, the surface tension of the molten mineral forces the droplet into a perfect tiny sphere. This is the birth of what scientists call a spherule. By the time the grain reaches the cooler, denser layers of the atmosphere lower down, it has already begun to solidify again. The heat dissipates into the surrounding air, and the liquid sphere freezes back into a solid, preserving its roundness forever. These cosmic spherules are like miniature marbles, often no larger than the tip of a fine needle. When viewed through a powerful lens, their beauty is revealed in startling detail. Some are deep charcoal black, with a surface that looks like hammered metal or polished obsidian. Others are translucent, appearing like tiny amber-colored bubbles or beads of clear glass. Because they were once molten, their surfaces are often incredibly smooth, reflecting the light with a soft, quiet glow. They are the ultimate survivors, their roundness a silent testimony to the trial by fire they endured to reach the surface of our world. Imagine a handful of these cosmic marbles scattered across the palm of your hand. They would be so light that you wouldn't even feel them resting against your skin. Yet they carry the history of the solar system within their glassy structures. Some might contain tiny bubbles of gas trapped inside the moment they solidified, bubbles of a vacuum that existed millions of miles away. Others might have tiny crystals embedded in their surfaces, like microscopic jewels set into a crown. They are delicate, beautiful, and strangely perfect. However, the journey from the top of the atmosphere to a place where a human can find them is long and full of obstacles. While these pharaohs are landing everywhere all the time, finding one is like trying to find a specific grain of sugar in a desert of sand. For most of modern history, scientists believed that the only way to find these particles was to travel to the most isolated, untouched parts of our planet. They sought out places where the Earth's own natural processes wouldn't hide the stars. They looked toward the vast white silence of the frozen poles, believing that only in the pristine ice could a piece of space truly be seen for what it is. This search for the cosmic among the terrestrial is a story of incredible patience, leading researchers to the coldest reaches of the globe in a quest to gather the dust of the heavens. This great search for the cosmic among the terrestrial began in the most remote corners of our world. For many decades, the scientific community operated under a firm belief. If you wanted to find a piece of the stars, you had to go where the Earth was at its cleanest. They looked toward the vast white silence of Antarctica. It was thought that only there, in the deep freeze of the southern pole, could one hope to isolate a single grain of space dust. The logic was simple and elegant. Antarctica is a giant frozen archive. When a micrometeorite falls onto the ice, it stays there, trapped in a pristine layer of snow that eventually turns into clear, blue glacial ice. Because there are no factories, no cars, and very few people, there is almost no local dust to confuse the search. A tiny dark speck found in a core of Antarctic ice is much more likely to be a traveler from the asteroid belt than a bit of soot from a chimney. Scientists would spend months in the bitter cold, melting tons of ancient ice just to recover a few precious milligrams of material. They filtered the water through incredibly fine meshes, hoping to catch those tiny glassy spheres we spoke of earlier, and they were successful. These expeditions provided us with our first real look at the chemistry of the early solar system, but it reinforced this idea that cosmic dust was a rare treasure, hidden away in the most inaccessible places on our planet. It created a boundary in our minds, a line between the pure space above and the noisy world we live in. The difficulty of finding a space grain among billions of Earth grains is hard to overstate. Imagine standing in the middle of a busy city intersection. Every time a car brakes, tiny particles of metal and rubber are released into the air. Every time a building is constructed, clouds of concrete dust and mineral fragments take flight. Even we, as humans, contribute to this. We are constantly shedding microscopic pieces of ourselves. In an urban environment, the ratio of Earth dust to space dust is overwhelming. It is estimated that for every single micrometeorite that lands on a city roof, there are millions, perhaps billions, of particles of human-made debris. To the scientists of the 20th century, searching for a micrometeorite in a city was seen as a hopeless task. It was like trying to hear a single whisper in the middle of a thundering waterfall. The noise of our civilization was simply too loud. Most experts believed that once a piece of cosmic dust entered our atmosphere, and drifted down toward a populated area. It was effectively lost forever, swallowed up by the gray tide of industrial pollution. But as we settle into the quiet of the night, it's worth considering that sometimes the most profound discoveries are hidden in plain sight. We often assume that because something is difficult to find, it must be far away. We look to the horizons, to the poles, and to the mountaintops, forgetting that the same sky hangs over our own homes. The breakthrough that would change everything didn't come from a multi-million-dollar expedition to the ice. It came from a shift in perspective, a realization that the stars might be much closer than we ever dared to imagine. As you rest, consider the possibility that the boundary between the pristine and the ordinary is thinner than we once thought. The stardust doesn't choose where to land based on how quiet a place is. It falls with a beautiful, indifferent regularity over the entire face of the earth. It was a man named John Larson who decided to challenge the long-held belief that our cities were too cluttered, too noisy, and too dirty to reveal the secrets of the stars. For a long time, the scientific world lived with a quiet, comfortable assumption. If you wanted to find something as pure and ancient as a micrometeorite, you had to go to the ends of the earth. You had to search the blue ice of Antarctica or the silence of the deep sea floor. The idea of finding a piece of the early solar system on a rooftop in Oslo or Paris seemed almost absurd. It was like looking for a diamond in a landfill. Larson, a jazz musician with a deep, patient curiosity, began a journey that many experts thought was a fool's errand. He started by looking at the dust on his own porch, then moved to the flat, gravel-covered roofs of industrial buildings and ordinary homes. He spent years meticulously collecting buckets of grit from rain gutters and rooftop drains. To most people, this was just dirt, the gray, gritty residue of urban life. It was the byproduct of car brakes, the soot from chimneys, and the tiny fragments of asphalt worn away by the rain. The reason no one had looked there before was rooted in a very practical concern: human pollution. In an urban environment, the noise of civilization is staggering. Every time a train passes, every time a construction crew cuts through concrete, and every time a car tire turns, thousands of microscopic particles are launched into the air. Scientists believed that this industrial background noise was so overwhelming that it would be impossible to find a single microscopic space grain hidden among the billions of human-made ones. It was a matter of probability. Why spend a lifetime searching through the grime of a city when you could go to the South Pole and find a sample that was relatively clean? But Larson's breakthrough came from a place of immense patience. He understood that while the city was indeed dirty, it didn't mean the stardust wasn't there. It was simply camouflaged. He realized that the same gentle rain of cosmic material that falls on the pristine glaciers of the north also falls on the shingles of your house, the hood of your car, and the sidewalk where you walk each day. The stars do not discriminate between the wilderness and the metropolis. As he spent thousands of hours peering through a microscope at his rooftop samples, he began to see something beautiful. Among the jagged, irregular shards of human-made debris, the sharp edges of glass and the twisted bits of metal, there were occasional perfect shapes. He found tiny glassy spheres, some no larger than the tip of a needle, that looked entirely different from anything produced by a factory or a car engine. These were the urban micrometeorites. The payoff of his discovery was profound. It proved that we don't need to travel to the most remote corners of the globe to touch the cosmos. The dirty nature of our cities had acted as a mental barrier, a reason to stop looking. We had assumed that our own presence on this planet had somehow pushed the wonders of space out of reach. But Larson showed that the stardust is always there, settling quietly into our gutters and resting on our windowsills, waiting for someone to take the time to notice it. The realization that the stars are literally under our feet, even in the busiest cities, changes the way we think about the world around us. It turns an ordinary rooftop into a landing strip for the universe. However, finding these tiny treasures is only the first step. Once you have a bucket of dust from a city roof, the real challenge begins. How do you separate a piece of a 4-billion-year-old asteroid from a tiny speck of a neighbor's roof tile? To solve that puzzle, scientists have to look for a very specific, invisible signature, a hidden quality that allows these cosmic travelers to reveal themselves. The secret to identifying these tiny voyagers among the vast landscape of ordinary dust lies in a quality they share with the very core of our planet, magnetism. As these particles streak through the upper atmosphere, the intense heat of their descent causes a quiet chemical transformation. The iron within them reacts with the surrounding oxygen, forming a mineral called magnetite. This magnetite acts like a tiny internal compass, a magnetic fingerprint that separates the celestial from the terrestrial, while the bits of rubber from a car tire, the flakes of dry skin, or the fibers of a wool sweater are indifferent to a magnet. These children of the stars are drawn to it with a silent, invisible pull. Imagine standing by your garden's rain gutter on a quiet, overcast afternoon. The rain has done the heavy lifting for you, washing the accumulation of seasons off the roof tiles and concentrating it into the downspout. If you were to take a simple magnet, perhaps a strong one wrapped in a thin layer of plastic to keep it clean, and slowly, methodically sweep it through the damp silt at the bottom of that gutter, you would be engaging in a form of cosmic fishing. It is a slow, meditative process. You are not looking for gold or silver, but for something far older and more traveled. When you lift the magnet from the silt, you might see a fine, dark powder clinging to the plastic. To the naked eye, it looks like nothing more than common soot or iron filings from a nearby workshop. But within that dark metallic fuzz, hidden like gems in a mountain of coal, are the micrometeorites. This is the moment where the scale of the universe shrinks down to something you can hold between your thumb and forefinger. You are holding the remnants of asteroids that have been drifting in the cold dark for billions of years, finally caught by a simple tool in a suburban backyard. When you take this magnetic dust and place it under the lens of a microscope, the mundane world of the city falls away. The jagged, irregular shards of human industry, the sharp-edged glass, and the twisted bits of industrial slag remain, but the space dust reveals itself through its unmistakable geometry. Under the magnification, the fuzz transforms into a collection of breathtaking shapes. You might see a spheral, a perfect tiny globe that looks like a dark polished pearl. Others might be shaped like delicate teardrops their forms frozen mid-flight as they cooled and solidified in the thin, cold air of the stratosphere. Some of these particles have a texture known as scoria, looking like miniature pieces of volcanic rock, pockmarked with tiny holes where gases escape during their brief fiery melting. Each one is a unique sculpture, carved by the laws of physics and the friction of our atmosphere. They are tiny, aerodynamic masterpieces. As you gaze at these shapes through the lens, you realize that the dirt of our world is actually a veil. And once you have the right tool to lift it, the elegance of the solar system is revealed in every handful of dust. Yet, the magnetic shell is only the outer casing. Deep within these grains, hidden from the naked eye, are crystalline structures that hold even more colorful secrets. If you were to peer even deeper into these microscopic treasures, looking past the dark, scorched crust that formed during their fiery descent, you would discover a hidden world of crystalline beauty. Within the heart of many micrometeorites lies a mineral called olivine. To a geologist, it is a magnesium iron silicate, but to the rest of us, it is something much more poetic. On Earth, when olivine is of high enough quality, we call it peridot, a gemstone of a striking translucent green like the color of a sunlit forest canopy or a shallow mossy spring. Imagine for a moment the journey of such a particle. It began its existence billions of years ago, perhaps in the cooling leftovers of a distant supernova or within the crushing gravity of a growing asteroid. It spent an eternity in the absolute cold of the interstellar void, a tiny, glittering, emerald-colored seed drifting through a sea of nothingness. When it finally encountered the Earth's atmosphere, the outer layers of the grain melted and fused, creating a dark, glassy shield. But inside, protected from the heat, the ancient green crystal remained unchanged. It is a soothing thought to realize that as you lie here, perfectly still, the sky is quietly raining gemstones. They are too small for us to wear as jewelry, of course, but their presence is a reminder of the shared chemistry of the cosmos. Olivine is one of the primary components of the Earth's mantle, the vast hot layer of rock that sits miles beneath your bed. To find it in a speck of dust from the stars is to see the inherent unity of the universe. The same materials that form the deep foundations of our planet are also floating in the thin, cold air of the upper atmosphere. When scientists slice these tiny grains into thin sections and pass polarized light through them, the olivine glows with a vibrant, ethereal light. It reveals a complex, orderly structure, an arrangement of atoms that has stayed exactly the same for billions of years. These crystals are the fundamental building blocks of the rocky worlds. Every mountain you have ever climbed, every canyon you have peered into, and every grain of sand on every beach began as these same basic materials swirling in the dark. These green crystals connect us to the history of our own solar system, to the time when the planets were first beginning to cool and harden from a chaotic disk of fire and dust. They are the fingerprints of our celestial neighborhood. Yet, as ancient as these olivine crystals are, they are not the oldest things the dust has to offer. Some of the particles we find in the quiet corners of our world have a history that stretches back even further into a time before the earth was born, before the sun began to shine, and before the very idea of a solar system had even taken shape. These are the travelers from the deep past, the grains that saw the galaxy before we were ever here to witness it. Take a slow, deep breath, feeling the air move gently in and out as we consider the true depth of time. While the olivine crystals we spoke of are ancient, they are children of our own solar system. Yet, hidden among the dust falling silently through the night air, are travelers of an even more profound age. These are known as pre-solar grains, and they are quite literally the oldest solid objects any human has ever encountered. They existed long before our sun began to glow, before the earth was a solid sphere, and before the very concept of a home had a place in this corner of the universe. Imagine a time more than 4.5 billion years ago. The space where our solar system now sits was not empty, but it was dark. A cold, quiet nursery of gas and dust. Within that vast, shadowy cloud drifted these tiny specks, forged in the cooling atmospheres of aging stars, or the violent, brilliant deaths of distant supernovae that occurred long before our own star was even a flicker of light. They are the survivors of a previous age of the galaxy, while most of the material in that original cloud was eventually vaporized and recycled when our sun ignited. These few incredibly hardy grains remained intact. They are like tiny, microscopic ghosts of stars that no longer exist, preserved in the cold amber of the void. The age of such a particle is staggering to consider, almost too large for the mind to hold. If you were to hold a single pre-solar grain on the tip of your finger, you would be touching something that has endured for billions of years. It was present when the first ripples of gravity began to pull the great cloud of gas together. It was there when the center of that cloud grew dense and hot, marking the long, slow birth of our sun. It has traveled through the vacuum for an eternity, silent and unchanged, while here on Earth, continents rose and fell, and oceans formed and evaporated. There is a quiet, steadying power in something so small and yet so resilient. It is a reminder that we are part of a much longer story, a narrative that stretches back into the deep velvet folds of time. These grains were the very first solid things in our neighborhood of the galaxy. They provided the foundation, the tiny anchors around which other materials could begin to gather. As the young sun began to stabilize and push back the darkness with its first rays of light, the leftover gas and dust didn't simply drift away. Instead, it began to flatten out, spinning slowly like a great glowing disk of light and shadow. This was the protoplanetary disk, a vast, swirling whirlpool of potential. And within this disk, our ancient pre-solar grains began to meet other particles, beginning a process of connection that would eventually lead to the creation of the very world you are resting upon tonight. In that swirling ancient disk of gas and dust, something quiet and remarkable began to happen. It wasn't a violent collision or a sudden burst of energy, but a very gentle, persistent attraction. As the tiny grains of cosmic dust drifted through the void, they began to find one another. In the stillness of the early solar system, these microscopic particles were governed by the same simple force you might notice on a dry winter's day, when you touch a doorknob or see a stray hair cling to your sleeve, static electricity. Because these particles were so small and the space between them was so quiet, the tiny electrical charges on their surfaces were enough to make them stick together. They didn't just drift past one another anymore. They began to cluster. If you've ever looked under a bed and seen a soft gray dust bunny, a delicate tangle of fibers and fluff held together by nothing more than stillness and static, then you have seen a small-scale version of how our world began. In the beginning, these cosmic dust bunnies were fragile and airy, drifting through the dark. But as they gathered more and more material, they grew. Slowly, over thousands of years, the clusters became the size of pebbles. Those pebbles, through the quiet persistence of gravity and motion, eventually collided and merged into rocks. The rocks became boulders, and the boulders became planetesimals, giant, wandering chunks of stone and ice miles across. It is a beautiful thought to hold as you drift toward sleep, the solid ground beneath your bed, the mountains that touch the sky, and the deep, silent floors of the oceans are all, in essence, just vast, ancient collections of dust. Every continent is a testament to the power of small things coming together. We often think of the earth as a massive, immovable fortress of rock, but at its heart, it is a giant, settled pile of cosmic dust, a collection of trillions upon trillions of those tiny, glittering grains that once drifted alone in the dark. You are resting on a world built from the stars, a massive sphere of stardust that has found its place in the sun's warm embrace. This process of gathering and growing was not a hurried one. It took millions of years of patient drifting and gentle collisions. Even now, as the solar system has settled into its familiar rhythm, the dust continues its journey, though the rules of the game have changed slightly. The very light from our sun, which provides us with warmth and life, also plays a subtle, invisible role in how the remaining dust moves through the void, acting as a soft, ghostly hand that guides the smallest particles on a long, slow path toward the center of our world. As you rest, imagine the sun not just as a source of warmth and light, but as a gentle, invisible force acting upon everything in its reach. In the vast, quiet space between the planets, there is a subtle phenomenon known to scientists as the Poynting-Robertson effect. It is a long name for a very soft and patient process. To understand it, imagine you are walking through a very light, misty rain on a day with no wind. Even though the rain is falling straight down because you are walking forward, the droplets seem to hit your face and chest more than your back. Your own movement creates a tiny bit of resistance against the mist. In the solar system, cosmic dust grains are like those travelers in the mist. As they orbit the sun, they are constantly bathed in sunlight. This light carries a tiny amount of momentum, and as the dust grains absorb and then re-emit this energy while they move, it creates a microscopic drag or a very gentle break. It is a force so small it could never be felt by something as large as a person or even a pebble, but for a speck of dust, it is enough to change its destiny. Over millions of years, this solar breaking causes the dust particles to lose a tiny bit of their orbital energy. They begin to drift away from their original paths, spiraling slowly, inch by inch, toward the center of the solar system. You might visualize the inner solar system as a giant, incredibly slow-motion drain. Every grain of dust that isn't gathered up by a planet or burned away by the sun's heat is participating in this long, graceful spiral inward. It is a cosmic dance of patience, a silent journey that takes ages to complete as the light of the stars themselves guides the dust home. Because we knew the space around us was filled with these ancient traveling grains, scientists became curious. They wanted to see these particles in their purest form before they had spent weeks drifting through our own thick atmosphere or landing in the dust of a city rooftop. They wanted to catch the dust while it was still fresh from its journey across the void. This curiosity led to one of the most poetic missions in the history of space exploration. NASA's Stardust mission. Launched into the velvet blackness of space, the Stardust spacecraft was designed with a single, beautiful purpose: to fly through the wake of a comet and catch the tiny crumbs of the universe as they flew by. But catching a particle of dust in space is not like catching a ball. These grains travel at speeds many times faster than a bullet. If they hit a solid metal plate, they would simply vaporize into a puff of gas, leaving nothing behind to study. To solve this, the scientists had to create something as soft and welcoming as a cloud of substance that could catch a piece of the stars as gently as a pillow catches your head at the end of a long day. To capture these microscopic treasures without destroying them, scientists turn to a material that seems like something out of a dream. It is called aerogel. If you were to hold a block of it in your hand, you might think you were holding nothing at all. It is a translucent, pale blue solid that is so thin and airy, it has earned the nickname frozen silky. Because it is composed of nearly 99% air, it is the lightest solid in the world. It looks like a captured piece of the sky, a hazy, ghost-like substance that feels almost weightless, yet it is strong enough to withstand the incredible heat and pressure of space travel. In the year 2004, the Stardust spacecraft extended a collector shaped like a large tennis racket, its surface filled with these delicate tiles of frozen smoke. As the ship passed through the shimmering, dusty veil of a comet known as Wild 2, the aerogel acted as a gentle cradle. When a particle of comet dust, traveling at thousands of miles per hour, many times faster than a bullet, struck the aerogel, it didn't explode or vaporize. Instead, the frozen smoke absorbed the energy of the impact, allowing the particle to burrow deep into the material. The dust grains slowed down gradually, creating a tiny tapered path, a microscopic carrot-shaped tunnel, until it came to a complete and peaceful rest, perfectly preserved and unharmed. Imagine the patience required for such a journey. For 2 more years, the spacecraft carried these tiny passengers back toward our home, protecting them in their smoky beds. In the early morning hours of a cold January day in 2006, a small capsule detached from the main ship and began its final descent. It streaked across the night sky like a man-made shooting star before opening its parachute and drifting down toward the Earth. It landed in the soft, dark sands of the Utah desert, a quiet ending to a voyage of nearly 3 billion miles. The silence of the desert night welcomed back the travelers that had spent eons wandering the cold reaches of the outer solar system. When the scientists finally opened the capsule in a sterile lab and peered into the tiles of aerogel, they saw what they had been searching for. Thousands of tiny dark specks trapped in the frozen smoke, visible only under a microscope. These were the first samples of a comet ever returned to Earth. Pristine pieces of the early solar system that had been frozen in the deep cold for billions of years. As they began to analyze these microscopic grains, they realized they weren't just looking at ancient space rocks. They were looking at a map of where we came from. The dust contained complex chemistry, far more intricate than anyone had expected. It was as if the comet had been a messenger, carrying a cargo of ancient ingredients across the vastness of time and space, waiting for us to finally reach out and catch them. These samples began to whisper a story about the very origins of life, a story that suggests the stars, the dust, and the very cells in our bodies are much more closely linked than we ever dared to imagine. As we study these bags of frozen smoke, we are finding that the ingredients for everything we know were drifting through the dark long before the Earth was even born. Take a slow, deep breath now. As you exhale, imagine that incredibly soft substance we spoke of, the aerogel. Picture it as a microscopic pillow of frozen smoke, waiting in the silence of deep space. When a tiny grain of dust from the comet Wild 2 approached the spacecraft, it didn't strike with a harsh or violent impact. And instead, the aerogel opened its arms, catching the traveler as gently as a feather landing on a velvet cushion. There was no sound, no heat, just a soft, gradual slowing down until the dust was held perfectly still, cradled in a translucent web of air and glass. It is a comforting thought. This tiny piece of the universe, after billions of years of wandering, finally finding a soft place to rest. Inside those tiny captured specks, scientists discovered something that changed how we view our own existence. They found a molecule called glycine. Glycine is an amino acid, one of the fundamental building blocks used by every living thing on our planet to create proteins. It is a humble molecule, yet it is essential for the architecture of life. Finding it out there in the cold, dark heart of a comet was like finding a single familiar word written in a vast alien library. It told us that the chemistry of life isn't unique to our small blue world. It is woven into the very fabric of the cosmos, drifting silently through the void. This discovery fueled a beautiful and profound theory. Imagine the early Earth, billions of years ago. It was a barren, rocky world, cooling under the light of a young sun, and all the while it was being showered by this cosmic dust. Trillions upon trillions of tiny grains, each one a microscopic delivery vessel. These grains weren't just bringing minerals and metals, they were carrying the ingredients for life itself. Like a gardener scattering seeds over a fresh field, the universe was dusting the young Earth with the organic compounds needed for the first cells to eventually wake up. It is a peaceful thought to consider that the very essence of what makes us human, the proteins in our muscles, the enzymes in our blood, might have started as a fine, invisible mist drifting through the interstellar void. We are, in a very literal sense, the gathered harvest of a cosmic sowing that took place eons ago. Every time you breathe, every time your heart beats, you are using materials that were once part of that ancient, wandering dust. We are not separate from the stars. We are the stars' way of coming together and breathing. But as vital as these chemical building blocks are, they need something else to flourish. They need a medium, a cradle of their own where they can mix and react and grow. They need water. And as we look closer at these tiny travelers from the stars, we begin to see that they may have brought more than just the seeds of life. They may have brought the very oceans themselves, one microscopic drop at a time. The story of our world is not just written in stone, but in the liquid that flows through our rivers and fills our seas, a liquid that may have had a very long, cold journey through the dark before it ever reached your glass. Think of the vastness of the Pacific Ocean or the deep rhythmic pulse of the Atlantic. It feels so permanent, so deeply rooted in the infinity of our planet. But for a long time, planetary scientists have wrestled with a beautiful mystery. Where did all this liquid come from? When the Earth was first forming, it was a hot, molten ball of rock, glowing with the heat of its own creation. Any water present in those early days would have likely evaporated and been swept away into the void by the solar wind. The water we see today, the rain that taps softly on your window, the mist that hangs over a morning meadow, likely arrived much later. It was a gift from the outer reaches of the solar system, delivered in a slow, steady, and silent procession. Some scientists believe that much of Earth's water was brought here by the very dust we have been discussing, along with its larger cousins, the icy asteroids. Imagine a single grain of cosmic dust floating in the cold, dark shadows of the outer solar system, far beyond the warmth of the sun. Out there, these grains are often coated in a thin, delicate layer of ice, tiny frozen reservoirs drifting through the silence. These are the snowflakes of the cosmos. As our young Earth moved through its orbit, it acted like a giant magnet, sweeping up these icy particles by the trillions. Each grain brought only a microscopic amount of moisture, a fraction of a drop. But the universe operates on a scale of time that is difficult for us to truly grasp. Take a moment to imagine a glass of water sitting on a table nearby. It is clear, cool, and perfectly still. Every single molecule in that glass has a history that stretches back through the eons. Before it was in your glass, it might have been part of a cloud, a rushing river, or the deep crushing pressure of an ancient sea. But if you trace its journey back even further, to the very beginning, those molecules were once frozen crystals clinging to a piece of stardust. They were travelers in the dark, wandering for millions of years before they finally found a home here. When you take a sip of water, you are, in a very real sense, drinking the ancient remnants of the early solar system. The very liquid that sustains your life, that keeps your cells hydrated and your heart beating, is a cosmic traveler that has finally come to rest. Over the course of 4.5 billion years, this quiet rain of icy dust and water-rich debris transformed our world. What began as a dry, rocky orb scorched by the sun slowly became the blue marble we recognize today. It is a profound testament to the power of small things. While 100 tons of space material a day might seem like a modest amount in the context of a whole planet, when you multiply that by billions of years, the accumulation is staggering. You get the crushing depths of the Mariana Trench. you get the vast white expanse of the Antarctic ice sheets. The oceans are, in essence, a massive liquid collection of melted stardust. As this water settled, it began to fill the low basins of the crust, creating the first seas. And as the water fell, the dust fell with it, sinking through the waves. In the stillness of the deep, a new kind of history began to be written, not in the air or on the rooftops, but in the dark, silent mud of the ocean floor, where the stars and the earth finally meet in the abyss. Imagine that tiny grain of dust we've been following, having traveled through the biting cold of the vacuum and the searing heat of the atmosphere, now beginning its final descent through the deep blue silence of the ocean. The journey from the surface of the sea to the very bottom is not a quick one. For a particle so small, the water feels thick, almost like honey. It drifts downward, swaying in the slow, rhythmic currents of the deep, sinking further and further away from the light of the sun. As it descends, the vibrant blues of the surface fade into a dim twilight, then into a midnight purple, and finally into a velvety absolute black. Down here, in the deepest parts of the world's oceans, regions known as the abyssal plains, there is a stillness that is difficult to find anywhere else on Earth. The pressure is immense, the temperature is just above freezing, and the silence is total. In these remote places, far from the reach of river silt or the sand of coastal beaches, the seafloor is covered in a very specific kind of sediment known as red clay. This clay is incredibly fine, and it accumulates at an impossibly slow rate, sometimes only a few millimeters every 1,000 years. Because so little material from the continents reaches these depths, the red clay becomes a quiet archive of everything that falls from the sky. If you were to travel to the bottom of the Pacific Ocean and run your hand through this soft, ancient mud, you would be touching a concentrated graveyard of the stars. Mixed into the clay are countless cosmic spherules, those tiny glassy marbles of space material that melted during their passage through our air. In the silence of the abyss, the stars have quite literally settled into the earth. It is a beautiful thought to hold as you relax your body, that the highest points of the heavens eventually find their way to the deepest, most peaceful parts of our world. Take a slow, gentle breath in and let it out. As you lie there, feel the weight of your own body settling into your bed, much like those tiny particles settling into the soft red clay of the ocean floor. There is no rush. There is only the slow, steady passage of time. Scientists often seek out these deep-sea sediments because they offer a pristine record of our solar system's history. When they dredge up samples of this mud from miles below the surface, they can use magnets and filters to separate the cosmic grains from the earthly clay. Each spherule they find is a tiny time capsule, preserved in the cold and the dark for millions of years. But the story these grains tell doesn't just begin when they hit our atmosphere. Before they ever reached the Earth, and long before they sank into the deep sea mud, these particles spent an eternity wandering the open void between the planets. During that long trek, they were changed by the environment of space itself. They were constantly washed in an invisible rain of energy, the cosmic rays that stream out from the sun and from distant, exploding stars. This exposure leaves a permanent mark on the dust, a kind of cosmic signature that scientists can read to understand exactly where a grain came from and how long it spent traveling through the lonely dark before it finally found its way to us. As these tiny grains rest in the deep sea mud, they carry a secret history of their journey through the void. It is a history written in the very atoms that make them up. You might think of it as a cosmic tan. Just as your skin might change after a long day spent under the warmth of the summer sun, a speck of cosmic dust is physically altered by its long exposure to the radiation of space. Inside these microscopic stones, scientists find traces of neon isotopes. Specifically, they look for a form called neon-21. This isn't neon like the bright, buzzing signs of a city street. It is a quiet, noble gas trapped deep within the mineral structure of the dust. These neon atoms are created when high-energy cosmic rays, particles moving at nearly the speed of light, strike the dust grain as it floats through the vacuum. Because these rays can penetrate the surface of the grain, they act like a celestial stopwatch. The more neon-21 a grain contains, the longer it has been wandering in the open spaces between the planets, unprotected by the magnetic field or atmosphere of a world. Take a moment to breathe in slowly, feeling the stillness of the air around you. Imagine that long, quiet journey. No noise, no rush, just a single grain of sand drifting through a cathedral of stars. By measuring these isotopes, researchers have discovered that some of the grains landing on your roof or settling into the ocean floor have been traveling for a staggering amount of time. While we measure our lives in years or decades, these particles measure theirs in millions. A single grain might have spent 10, 20, or even 40 million years drifting through the silence, slowly spiraling inward from the cold reaches of the asteroid belt or the distant orbits of the outer planets. It was traveling when the ancestors of the creatures we know today were first appearing on Earth. It was traveling through the dark while mountains were being pushed up toward the sky and oceans were shifting their boundaries. It has seen our planet change from a distance, a blue marble growing ever so slowly larger in its field of vision, until finally it was caught by the very edge of our air and brought to a gentle rest. Most of these particles are local. They were born from the collisions of asteroids or the melting of comets within the neighborhood of our own sun. They are part of our family, made of the same original cloud of gas and fire. But every now and then, scientists find a grain that tells a much older, much stranger story. These are the grains whose tan is different and whose chemical signatures suggest they didn't start their journey anywhere near our sun. They are the interstellar travelers, the messengers from the vast, deep space that lies beyond the borders of our solar system. Even as you sleep, these tiny visitors from other star systems are crossing the threshold into our world, bringing with them the secrets of the galaxy at large. As you lie there, perfectly still, our entire solar system is on a journey of its own, sailing through the vast, dark ocean of the Milky Way galaxy. We are not just sitting in a static void, we are moving at incredible speeds, passing through different neighborhoods of space. Right now, and for the last several thousand years, our sun and all its planets have been drifting through a region known as the local interstellar cloud. It is a wispy, ethereal patch of gas and dust about 30 light years across, that is slightly warmer and denser than the space surrounding it. Though we call it a cloud, it is thinner than the finest mist you could ever imagine, so thin that if you were standing in the middle of it, you would see nothing but the clear, deep black of the cosmos. But even this thin mist contains tiny messengers. These are the interstellar grains, particles that were born around other stars, perhaps thousands of light years away, and have been wandering the galaxy for eons before crossing into our territory. To enter our solar system, however, these tiny travelers must first cross a border. Imagine the sun as a great glowing heart, constantly beating and sending out a steady stream of charged particles called the solar wind. This wind flows outward in every direction, creating a massive, protective bubble that surrounds us, extending far beyond the orbit of Pluto. Scientists call this bubble the heliosphere. It acts as a majestic shield, a magnetic frontier that deflects much of the harsh radiation and debris from the deep galaxy, pushing it away like the bow wave of a ship moving through water. As you take a slow, deep breath, imagine this invisible bubble shimmering at the very edge of our world, standing guard against the pressures of the interstellar wind. Most of the dust from the galaxy at large is swept aside by this shield, never getting the chance to visit our inner planets. But the smallest, most persistent grains, particles so fine they are almost like ghosts, manage to slip through. They are small enough that the magnetic forces of the sun don't catch them, allowing them to pierce the veil of the heliosphere and begin their long final descent toward the sun. These grains are different from the local dust we have been discussing. They do not belong to our sun's family. They are outsiders, carrying a chemical signature that speaks of different stars in different corners of the galaxy. When they cross that border, they don't drift in slowly like our local asteroid dust. They come with a momentum all their own, a sense of purpose born from the motion of the stars themselves. You might think of them as tiny, silent stowaways. While our local dust circles the sun in a predictable, rhythmic dance, these interstellar visitors are moving on a different path, cutting across the orbits of the planets with a unique trajectory. They are the only physical pieces of the wider galaxy that we can actually touch and study here on Earth. As they move deeper into our solar system, leaving the protection of the interstellar cloud behind and entering the space we call home, they begin to feel the gravity of our sun. But because they are coming from the outside, from the great elsewhere of the galaxy, they possess a quality that sets them apart from every other grain of sand on our planet. They are moving with a quiet, incredible intensity. Even as they approach the soft, welcoming embrace of Earth's atmosphere, they carry the energy of their long, interstellar trek, a speed that is far greater than anything born within our own celestial neighborhood. These travelers from beyond our sun are known to scientists as hypervelocity particles, a name that suggests a frantic energy, yet their journey ends in the most peaceful way imaginable. While the dust born within our own solar system, the crumbs of local comets and asteroids, drifts along at a relatively leisurely pace, interstellar dust arrives with a momentum that speaks of the vast distances it has crossed. These tiny grains streak through the void at a staggering 26 kilometers per second. To put that in perspective as you rest your head, that is nearly 60,000 miles per hour. At that speed, a particle could cross the entire United States in less than 3 minutes. It is a speed that belongs to the stars, and velocity born from the rotation of the galaxy itself. When these grains finally reach the very top of our atmosphere, you might expect a violent encounter. But the Earth is a gentle host, and its atmosphere is a master of deceleration. The air stretching miles above your room acts like a vast, invisible cushion. As the hypervelocity particle enters the uppermost layers of the thermosphere, it begins to brush against the first thin molecules of oxygen and nitrogen. The air is so sparse there that it doesn't provide a wall, but rather a soft, persistent resistance. One by one, these air molecules tap against the speeding grain, absorbing its energy, turning that incredible cosmic momentum into a faint, harmless glow of heat. In a matter of moments, the traveler is tamed. The atmosphere gently breaks the particle, cradling it as it sheds its interstellar speed. It transitions from a bullet from the deep galaxy into a silent, drifting speck, no longer driven by the forces of distant stars, but surrendered to the soft pull of Earth's gravity. It begins a descent that is as slow and rhythmic as a falling leaf in a windless forest. The violence of space is forgotten, replaced by the calm, steady physics of our home planet. As you lie there, perfectly still, try to feel the contrast between that immense cosmic journey and your own quiet moment. The universe is moving at impossible speeds, with particles crossing the light years at velocities we can barely comprehend. Yet here, in the safety of your room, everything is slow. Everything is soft. The air around you is still, and your breath is a steady, calming rhythm that connects you to the atmosphere that protects us all. Take a moment to simply exist in this stillness. The same air that catches the dust of the stars is the air that fills your lungs, cooling and grounding you. There is a profound peace in knowing that no matter how fast or far something travels through the blackness of space, the Earth knows how to welcome it home, slowing it down until it is ready to settle into the quiet corners of our world. Think of the journey that single grain has taken, from the explosion of a distant sun through the magnetic shield of the heliosphere, and finally through the soft embrace of our sky. It has survived the vastness and the speed. And now, it is just a tiny part of the world around you. It is no longer a guest. It is part of the landscape. As you drift closer to sleep, let the image of that soft, atmospheric breaking settle your mind. The rush of the day, the speed of your thoughts, and the momentum of your worries are all being caught by the quiet of the night, slowing down, losing their energy, and preparing to rest, just like the dust of the stars. You are here in the present, in the now. The world is turning beneath you. The stars are watching from above, and the air is a silent, protective blanket that keeps the chaos of the cosmos at bay. Everything is exactly where it needs to be. The journey is over for the day, and the time for rest has arrived. As we move from the grand scale of the galaxy back to the intimate space of your own home, you might begin to realize that the connection between the stars and your surroundings is much closer than you ever imagined. Even the very room you are in, The objects on your nightstand and the books on your shelves carry a silent, microscopic history of the universe, waiting to be acknowledged in the quiet of the night. As you settle deeper into your pillows, let your eyes drift across the room, perhaps toward the corner of a bookshelf, the top of a picture frame, or the quiet surface of a nightstand. In the soft, dim light, you might notice a thin silver veil of dust that has gathered there. It is a quiet, inevitable part of every home, a gentle layer that settles while we are busy living our lives. We are often told that the dust in our houses is mundane, that it is mostly made of us. Tiny, translucent flakes of skin, microscopic fibers from a favorite cotton blanket, or the colorful lint from a well-worn carpet. And for the most part, that is true. It is a reflection of our daily rhythms, a soft physical record of the time we spend in these private spaces. But if you were to look closer, much closer than the human eye allows, you would find something truly extraordinary hidden within that gray mist. Mixed in with the fibers and the cells is a tiny, almost invisible fraction of material that did not begin its journey on this planet. It is a beautiful, humbling thought to hold as you drift toward sleep, that even in the most enclosed, protected room, the universe finds a way to reach you. As you lie there in the stillness, the objects you cherish, your books, your keepsakes, the very wood of your bed frame, are all being gently dusted by the remnants of the stars. Think of your bookshelf for a moment. It is a place where you keep stories, histories, and dreams bound in paper and ink. But in the quiet of the night, it becomes a different kind of library, a library of the galaxy. Every few months, a new volume arrives in the form of a micrometeorite, a tiny shade of mineral that has traveled through the cold, silent vacuum for millions of years, just to come to rest near your favorite novel. It is a piece of the great outdoors, the greatest outdoors there is, settling into the most intimate corners of your life. This cosmic dust doesn't announce itself. It doesn't clatter against the window or glow with a fierce light. It simply drifts, weightless and patient, through the air of your room until it finds a place to stay. It is the ultimate traveler, a nomad of the void that has finally found a home. When you see that thin layer of dust tomorrow morning, you might look at it with a sense of wonder, knowing that among the ordinary bits of home, there is a glittering grain of the infinite. Among these tiny, silent travelers, there is a very special group that scientists look for with great care. They are known as carbonaceous chondrites. The name itself feels old and heavy, but the particles themselves are delicate and rare. These are not just bits of common rock. They are the most primitive materials in our entire solar system. They are the original dust, the raw matter that existed before the Earth was even a thought, before the sun had fully ignited its fire. These particles are like tiny dark seeds. They are rich in carbon, the same element that forms the basis of your own body, your breath, and the life outside your window. To hold one, or to have one resting on your shelf, is to be in the presence of a time capsule that has remained unchanged for over 4.5 billion years. They carry within them a chemical map of how everything began. As you let your muscles relax and your mind begin to wander, Imagine these ancient seeds floating softly through the air around you, dark, rich, and full of the secrets of the early universe, waiting to tell a story that began long before the first sunrise. These rare carbonaceous chondrites are the crown jewels of the cosmic dust world. While most micrometeorites are made of stone or metal, these particular grains are dark, porous, and incredibly complex. They are rich in organic compounds, not life itself, but the intricate carbon-based molecules that serve as the building blocks for everything living. As you breathe in the cool, still air of your room, imagine a tiny grain of this dark material resting nearby. It is a treasure chest of the ancient past, containing amino acids and water that has been locked away within its mineral structure since before the Earth was a solid sphere. Scientists view these specks as the ultimate time capsules. Most of the rocks we find on Earth have been recycled, melted by the heat of the mantle, or crushed by the shifting of tectonic plates. But these tiny grains are different because they have remained in the cold, frozen vacuum of space for billions of years. They have never been altered. They are the original recipe of our solar system, preserved in their most primitive state. When a scientist looks at one of these grains under a microscope, they aren't just looking at a piece of dust. They are looking at the very first moments of our history. A snapshot of the swirling cloud of gas and debris that eventually became the sun, the planets, and eventually us. The water held within these grains is perhaps the most poetic part of their story. It isn't liquid water like a raindrop, but rather hydroxyl molecules bound tightly into the clay-like minerals of the dust. This is old water, water that existed before the first oceans were poured. It is a humbling thought to realize that the life-giving moisture we depend on may have arrived on the backs of these tiny, dark travelers, drifting down through the atmosphere in a silent, billions of years long rain. But as precious as these particles are, they are incredibly difficult to find once they reach the ground. On the surface of the Earth, they become mixed with the dust of our own world, the pollen, the smoke, and the soil. To find these time capsules in their most pristine, untouched form, we have to look much higher in the thin, quiet layers of the atmosphere where the air is still and the world below seems like a distant memory. This quest led to the discovery of what scientists call Brownlee particles, named after Donald Brownlee, the visionary astronomer who first proved we could collect cosmic dust directly from the sky. These particles represent our most direct link to the deep reaches of space. To catch them, we had to leave the comfort of the ground and reach up into the very edges of the heavens, into a place where the atmosphere is so thin and silent that the only things moving are the wind and the falling stars. This high-altitude world is a realm of absolute peace, a place where the treasures of the universe can be gathered before they ever touch the soil of the earth. To reach these high, silent heights, NASA employs a very specific and elegant tool, the U-2 aircraft. You might recognize its name from history books, but in this peaceful context, it is a vessel for discovery, a high-altitude sailor navigating the very edge of our world. This plane is uniquely suited for the task because of its incredibly long, slender wings, which allow it to glide through air so thin it would barely support a traditional aircraft. It moves with a slow, rhythmic grace, far above the clouds and the weather that we see from our windows. On the wings of these planes, scientists have mounted small, specialized collection devices. Within these devices are tiny plates, often referred to as sticky pads or flags. These plates are coated in a very thin, clear layer of high viscosity silicone oil, a substance so pure and tacky that it can catch a microscopic grain of dust without damaging it. As the plane reaches its cruising altitude, these collectors are open to the sky. For hours, the plane drifts through the upper atmosphere, its sticky wings acting like gentle hands held out in a quiet snowfall, waiting for the treasures of the cosmos to settle upon them. The U-2 flies at an altitude of approximately 20 kilometers or 65,000 feet. This is more than twice as high as the commercial jets that carry travelers across oceans. At this height, the sky above the pilot isn't the bright, familiar blue we see during the day. Instead, it transitions into a deep velvety indigo, a color that hints at the vast, dark vacuum of space just a little further up. From this vantage point, the curve of the Earth is clearly visible on the horizon, a soft blue arc cradled by the darkness. Up here, in the stratosphere, the air is incredibly thin and extraordinarily still. It is a world of absolute peace. There are no birds here, no insects, and very little of the noise of Earth. Down on the surface, the air is thick with the signatures of human life: smoke from chimneys, dust from construction, and pollen from the trees. But the stratosphere acts as a natural filter. Because this layer of the atmosphere is so stable, very little of the dust from the ground ever makes it this high. This means that when a U-2 pilot opens those collection pads, the particles they catch are almost guaranteed to be from space. These are the Brownlee particles in their most pristine state. They are caught before they can be washed away by rain, before they can be stepped on, and before they can mix with the mundane dust of our everyday lives. When the plane finally descends and lands, returning from the quiet indigo heights to the warm, thick air of the airfield, the collection pads are immediately sealed in airtight containers. They are taken to clean rooms, environments more sterile than a hospital operating theater, where scientists use microscopic needles to pick off individual grains of stardust, one by one. In the stillness of the laboratory, these grains are revealed to be the same time capsules we spoke of, the ancient, icy, and mineral-rich fragments of comets and asteroids. Each one has been caught in the act of its long journey home. It is a beautiful, slow-motion harvest, a way for us to reach out and touch the universe without ever leaving our own atmosphere. But even if we didn't go up there to meet them, these particles would eventually find us. They are subject to the same quiet, invisible force that governs everything in our lives, a force that ensures that every piece of the stars, no matter how small, eventually finds its way down to the ground. Gravity is the final, most patient collector of all. It is the invisible thread that connects the smallest speck of dust to the very heart of our planet. While the U-2 planes and the high-altitude balloons reach up to meet the stars halfway, most of the cosmic dust completes its journey on its own, surrendered to the steady, gentle pull of the Earth. As these particles leave the stillness of the stratosphere and enter the lower layers of our atmosphere, their descent becomes even more of a whisper. Here, the air is thicker, more supportive, like a deep, clear ocean. A single micrometeorite might spend weeks or even months drifting through the air, dancing in the slow updrafts, and eventually, inevitably, sinking toward the ground. It is a journey of incredible scale, yet it happens in total silence. There is something deeply peaceful about the thought that the universe is constantly, softly, giving itself to us. Every hour of every day, this cosmic rain continues to fall. It lands in the ancient forests, where it is tucked away under layers of cool moss. It falls into the dark expanses of the oceans, where it sinks through miles of salt water to rest on the seabed for eternity. And it falls right where you are, settling on the windowsills and the garden paths, a literal piece of the heavens coming home to rest in the quiet of the night. When we look at this process, we are looking at the great, slow heartbeat of the universe. It is a cycle that has no beginning and no end. Stars are born in vast clouds of gas and dust, burning brightly for eons before they finally reach the end of their lives. In their final moments, they cast their treasures back into the dark, the carbon, the oxygen, the iron, and the gold they forged in their fiery cores. That dust wanders the void for millions of years, eventually finding its way to a new solar system, a new sun, and a new world. The very planet you are resting on is, in its essence, a giant, ancient collection of this cosmic dust. Everything we see, the mountains, the trees, the rivers, and even the air we breathe, started it as these tiny, drifting grains. And we, too, are part of that story. The atoms that make up your hands, your heart, and the thoughts drifting through your mind were once part of those same stars. We are not just living on a planet made of stardust. We are the stardust itself, awakened and aware, looking back up at the home we once knew. As you lie there now, feel the weight of your limbs as a gentle connection to that same gravity. It is the same force that gathered the planets together and the same force that brings the stars down to your roof. There is no rush and there is no distance that can truly separate us from the cosmos. The world outside is dark and still, and the sky is busy with its quiet work, sending down its microscopic gifts as you drift closer and closer to sleep. Everything is in its right place. The stars are far away, yet they are here with you, settling softly into the world while you rest. In this stillness, the boundaries between the earth and the sky seem to fade. We are part of a grand celestial recycling program, a journey that spans billions of years and trillions of miles, yet ends so simply and so quietly on a cool night like this. The dust that was once a part of a distant supernova now rests in the palm of the world, having completed its long descent through the dark. It is a reminder that we are never truly alone, and that the universe is always in its own slow way, reaching out to touch us. In the quiet time we have spent together tonight, the world has changed just a little bit. While you have been lying here, letting your breath slow and your mind wander through the silver clouds of the thermosphere and the dark reaches of the interplanetary void, the Earth has been busy collecting its nightly harvest. It is a staggering thought to consider that in the time it took to share these stories, thousands upon thousands of new particles have completed their billion-year journey. As you rested, several tons of cosmic material, the remnants of comets, the debris of ancient asteroids, and the soot of dying stars have softly touched down upon our planet. Some of those specks are landing in the vast uninhabited reaches of the Sahara, settling into the dunes. Others are disappearing into the white silence of the Antarctic ice. And some, quite possibly, have drifted down through the air right outside your window, settling onto the leaves of the trees or the roof above your head. The Earth is slightly heavier now than it was when you first closed your eyes, enriched by the arrival of these tiny celestial travelers. They have come from the furthest reaches of our solar system to rest here, in the same stillness that you are currently enjoying. As you feel the last lingering tension leave your body, let the realization wash over you that you are part of a living, breathing cosmos. There is no separation between the stardust drifting through the rafters of the galaxy and the life that flows through you. You are a child of the universe, made of the same light and the same ancient elements that have been traveling through the dark for eons. The same laws of physics that guide a micrometeorite to a soft landing are the laws that allow your heart to beat and your lungs to draw in the cool night air. You are safe. You are held by the same gravity that holds the moon in its orbit and the planets in their dance around the sun. The universe is not a cold, empty place, but a home filled with a glittering, constant rain of history. Every grain of dust is a story, and every story is a part of you. Now, let the weight of the world carry you down into the depths of a deep and restorative sleep. Imagine those tiny glassy spherules and the glittering grains of olivine settling all around the globe, a quiet cosmic blanket for a resting world. The sky will continue its gentle work while you dream, sending down its silent messengers to remind us where we came from. Take one last slow breath. Feel the stillness of the room. The journey is over for now, and the stars are watching over you. Sleep deeply. Sleep peacefully. May your dreams be as vast and as beautiful as the star-filled sky. Good night.